Hi, in this video I'm going to go through the evens from section 2.1 for all of those problems where we're finding a slope of a graph, aka the slope of the tangent line. So I urge you, if you're having trouble with these at all, do the initial steps exactly the way I do them. I'm going to do them much faster. I'm expecting that you can pause this video. But for every single one of these, I am going to begin. So here's problem number 18. I'm just doing the evens. The odds are checkable in the back of the book. I will begin by reminding myself of the general formula. I urge you, keep writing the general formula over and over again so that it sticks. Don't just look at it over and over again, write it over and over again. If you want to call things h instead of delta x, that's fine. I think I'm going to switch it up. So first thing, just write the general formula. Then we're doing problem number 18 here. So we're going to ask, we're trying to find the steepness at which value of x, and we'll notice it's at x equals 2, x equals negative 2. So I'm going to rewrite this formula where everywhere I see x, I will plug in negative 2. So first I write it as generically as possible, then I insert my x value. Now I will think about the formula for this particular function. And for this particular function, the formula is f of x equals 6. So this is the rather strange function where no matter what you plug in, the answer is 6. So with that in mind, I'm going to keep rewriting. You'll notice at every step, I account for everything. If it begins with a limit, I write the limit. If it's a fraction, I write the fraction. But what we just learned is for this function, it's basically saying the answer is always 6. So f of negative 2 plus delta x is 6. F of negative 2 is 6. So if we simplify our numerator there, we get 0. 0 divided by anything is 0. And we notice, oh, well, the limit here, we don't even have to plug in. The answer is 0. And that makes sense because what we would have graphed here is a horizontal line. Its steepness is 0. Let's look at problem number 20. I will begin by writing the most generic version of this formula for finding the slope of a graph. This time I'll use h. Keep writing the formula, don't leave out the limit. And I notice for this particular example, x equals 1. So now I will rewrite it just by inserting 1 everywhere I see x. Let me make this a little bit pretty. Now, what is the function here? So this is the function f of x is 6x plus 3. What does it do to its input? 6 times input plus 3. So let's do that here. The rule is 6 times input plus 3. So if I do this to f of 1 plus h, I will get 6 times input plus 3. F of 1 is equal to 9. You can get that by plugging in, or you will notice they actually told you that the corresponding y value is 9. But f of 1 is 9, that's easy to figure out. Now, let's do some algebra and hope things cancel. I have the limit as h approaches 0. Keep writing the limit, keep writing the fraction. Distribute that 6. What I will notice is that 6 plus 3 minus 9, all those constants cancel out. So I am left with 6h over h, which simplifies to 6, and so the answer is 6. This one also makes sense because the slope of the line, sorry, I'm talking too fast. This is a line with a slope of 6. We computed its steepness and got 6. That makes sense. Okay, number 22 is f of x is 11 minus x squared at 3, 2. I will begin by writing my generic formula for finding slope of a graph, steepness, slope of a tangent line. I'll switch back to the delta x version. Here is my generic version. I know my specific x value is 3, so I will write that next. And now I will ask, what does the function f do? Here is the formula, and it is 11 minus input squared. So I will apply that rule. If I apply that to, let's create brackets here. If I apply that rule to 3 plus delta x, again, the rule is 11 minus input squared. So this would be 11 minus 3 plus delta x squared. Over here, it would be 11 minus 3 squared. So now I'll do algebra and hope that things simplify. Let me add a page here. So I keep writing everything at every step. Even if it's cumbersome, just do it. You will forget sometimes. So if I FOIL that out, I get 9 plus 6 delta x plus delta x squared. If I distribute this negative, it's negative 11 plus 9, which is what I got from 3 squared. I will distribute a negative again. You'll note I keep writing that limit every single time. Here I am distributing that negative. And now let's hope we get some cancellation. I notice that I have 11 minus 11, so those cancel. I have negative 9 plus 9, so those cancel. So what I am left with in the numerator is negative 6 delta x minus delta x squared all over delta x. What's left in the numerator has a delta x I can factor out. The delta x I factored out cancels with the delta x in the denominator. So I have negative 6 minus delta x, and finally I can plug in 0, so my answer is negative 6. The last one in this group was number 26. I will write the generic formula. I will plug in my specific value of x. And now I will ask, what does this particular function do? Square root of input plus 1. So if I do that to 8 plus h, it is square root of 8 plus h plus 1. If I do that to 8, it is the square root of 8 plus 1. So let me just simplify a few things. I know that 8 plus 1 is 9, so I'm going to rewrite this first one as 9 plus h. Over here, 8 plus 1 is 9, and I'm taking the square root. The square root of 9 is 3, so I'm just going to write minus 3. So this is the limit we want to do. If we plug in, we get 0, and we notice we have radicals. So we're going to do that radical trick. So I will continue over here. So I have the limit as h goes to 0 of root 9 plus h minus 3 over h. And I will multiply top and bottom by that conjugate. So root 9 plus h plus 3 over root 9 plus h plus 3. In the numerator, I have this a minus b, a plus b rule, so it is the first thing squared, which is 9 plus h, minus the second thing squared, which is 9. So in the numerator, the 9's cancel and I have h. And I notice that h can cancel with the h in the bottom. My presentation here isn't great because I'm trying to cram it in. For the next ones, I'll make sure it's cleaner. So after I cancel, it looks like this. And if I plug in h equals 0, I get 1 over the square root of 9 plus 0 plus 3, which is 1 over 3 plus 3, which is 1/6. Now, in this next set, we're actually finding the equation of the tangent line and graphing to see if we've done this correctly. But first, let's find the slope. So this is the same thing we've done, but with an extra step. Here I will write my generic version of how do I find the slope of a tangent line. For number 42, my value of x is -4. My rule here is -1/8 times input squared. So -1/8 times this input squared minus -1/8 times this input squared. And we'll just do a bunch of simplification in algebra. If I FOIL out this part, I get 16 minus 8h plus h squared. Here I will notice these negatives cancel. -4 squared is 16. 16 over 8 is 2, so we have a plus 2 over here. I will distribute my -1/8. I will notice that the -2 cancels with the 2, and that everything left in the numerator has an h I can factor out. These h's cancel, so I have the limit as h goes to 0 of 1 minus 1/8 h. If I plug in 0, I get 1 minus 1/8 times 0, which is 1. So let's think about what we've learned here. We are trying to draw a tangent line for this graph at this point. What we have just learned is that the tangent line has a slope of 1. But it's the tangent line at this particular point. So I'm just going to draw a rough schematic. We have this graph. There's a point on that line at -4, -2. Here is the tangent line. Here is the tangent line. And its slope is 1, right? That's not a very good picture. But here's what we know. So now we can say we have just learned that we have a line whose slope is 1, and the point that we already know for that line is -4, -2. So we want an equation for that line, and I'm just going to do point slope form. Y minus my given y coordinate is slope times x minus my given x coordinate, which simplifies to y plus 2 equals x plus 4. Might as well simplify some more. We get y equals x plus 2. Now, the instruction is to actually test this. So I have Desmos ready to go, and I have all of them ready to go. So this is the graph we have in mind. One of the points is at -4, -2. And we just figured out, -4, -2. There it is on the graph. We just said that the tangent line will be y equals x plus 2. Let me change the color on this. And there we go. If we zoom in, that looks great. That is the line that basically captures the curve at that point. Right, so this is very checkable. So the first one checked, let's just delete it. Okay, the next one, I'm just doing the evens. 2x squared minus 5 at the point negative 1 comma 3. So first I'll find the slope. Same old, same old. First I'll write the most generic form. I'll switch back to the delta x version. The specific x value we want is negative 1. So I'll plug that in. And the rule here is 2 times input squared minus 5. I'm going to bracket these off. So for the first one, 2 times input squared minus 5. 2 times input squared minus 5. That's what I get if my input is negative 1 plus delta x. For the other one, two times input squared minus 5. Now we just simplify and hope that the algebra isn't so bad. So 2 times, if I FOIL this out, it's 1 minus 2 delta x plus delta x squared minus 5. Here I'll distribute, this is just the number 2, so it's minus 2 and plus 5. Now I'll distribute that 2 at the very beginning. So we have 2 minus 4 delta x plus 2 delta x squared minus 5 minus 2 plus 5 all over delta x. The 2 cancels with the negative 2, the 5 cancels with the negative 5. Everything left in the numerator has a delta x in it, so I'll factor that out. Those delta x's cancel. So we have negative 4 plus 2 delta x. Finally, we can plug in delta x equals 0, and we get negative 4. So what we have learned is that the slope is negative 4. The point is at negative 1 comma negative 3. I'm going to use point slope form. Y minus my given y coordinate is slope times x minus my given x coordinate. So y plus 3 equals negative 4 times x plus 1. I'm going to leave it like that. Let's see how we did. So now we have this one, and the point was at negative 1 comma negative 3. There we see it on the graph. And I said that that tangent line would be y plus 3 equals negative 4 quantity x plus 1. There we go. Perfect tangent line. Hits at that point, captures the direction perfectly. So another one where we can check that we absolutely did it correct. Okay, 2 more. Number 44 is another one with a radical. Okay, so to find the slope, limit as h goes to 0 of f of x plus h minus f of x all over h. X is equal to 6. And the function here is basically square root of input plus 3. So square root of input plus 3 minus square root of input plus 3. I keep writing the limit, I keep writing the fraction. If you don't write it, you might forget to put it back. So I have the square root of 9 plus h. This is the square root of 9, which is 3. This is very similar to the one we did before. And in fact, let's just check. So yeah, the other problem looked different in the setup, but it was actually the same limit. So we already did this work and we know it's 1/6. I'm not going to repeat it. Right? So there are different problems that reduce to the same limit, which is not unheard of. So we have learned that the slope of this line is 1/6, and the point we were given was at 6, 3. So in point slope form, y minus my given y coordinate is slope times x minus my given x coordinate. Let's see how we did. So let's just get rid of these. Here we go. There was a point at 6, 3. Oops. I keep switching back between using my keyboard and not. So here's our graph. There's the point at 6, 3. We said the slope was going to be 1/6. Y minus 3 equal 1/6 times x minus 6. And there we go. Right? When we zoom out, it's clearly a different thing. When we zoom in, really can't tell the difference. That's a good tangent line. And our last one, problem number 48. Algebra here is going to be a little tough. Don't panic about this. I'm certainly not going to put really tough algebra on one of these on the test because it's hard enough just to wrap your head around what you're doing. But down the road, we might see the hard ones more often. So it's worth practicing right now. Okay. So we know that that slope of the tangent line will be the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. My specific value of x is 2. And my rule here is f gives me 1 over input minus 3. So 1 over input minus 3 minus 1 over input minus 3. So let's try to clean this up. So this would be 1 over delta x minus 1 if I combine the 2 and the negative 3. This is negative 1. 1 over negative 1 is negative 1. With a minus in front, we actually have plus 1. So here's what we're going to do. First, I am going to simplify the numerator by creating a common denominator. Still writing everything at every step, even though I'm just working on the numerator right now. So because these have a common denominator, I can add them together, and I will get 1 plus delta x minus 1. And the 1 and the minus 1 cancel. So we have delta x over x minus 1. So now we have fractions involving, we have division involving fractions. If you have bad intuition about this, rewrite this as the fraction. So now we have fraction divided by fraction, which means we're taking the thing we had up top and multiplying by the reciprocal of the bottom. So up top we have delta x. In the bottom we have delta x minus 1 times delta x. These cancel, leaving us with the limit as delta x approaches 0 of 1 over delta x minus 1 And if we plug in, we have 1 over 0 minus 1, which works out to negative 1. So for this example, our slope is negative 1. And the point we were given at the very beginning of this process is 2 comma negative 1. So point slope form, y minus my given y coordinate is slope times x minus my given x coordinate. Let's clean this up a little bit. If I distribute the negative over here, and I can move the 1 over. So it looks like we get y equals negative x plus 1. Let's see how we did. So there's a point on this graph at 2 comma negative 1. And what did we say the tangent line would be? Y equals negative x plus 1. Let's see how we did. Y equals negative x plus 1. Change the color. There we go. Really good tangent line. If we zoom in, they look super close. So I know I went through this really fast. I would give you a maximum of one of these on the test, and I probably would make it so that the algebra is not ridiculously hard. But really pay attention to those initial steps, right? The most important stuff is at the beginning, because I think people are decent with the algebra once they get there. What is the pattern that we are applying? Specifically, what number goes in for negative, for what number goes in for x, and then which function are we applying? Keep using that word input. Don't get caught up on the name x. What does f do to its input? Do it here, and then do out all the algebra. Okay, that's it.